Steven's like, whatever, I've been done for 10 minutes.
Yeah, no, I'm speedy reading ready.
What was your reading?
I was having to translate the and.
What was my reading? Yeah.
And I never have to translate your handwriting.
My reading was
You can read that fast.
Oops.
Okay.
handwriting.
So, if we take the limit of, this is that problem from earlier. So we know that when we plug in 3, we get an indeterminate form.
Yeah.
We get 0 over 0. So according to this rule, we can take the limit as x approaches 3 of the derivative of the top. So 4x, go ahead.
4x minus 1.
Yep.
Over 2x minus 1.
And then let's plug that in.
4 times 3 minus 1 is 11 over 3. 5. No.
And what did we get earlier?
11.
Interesting. Interesting.
Much easier, much quicker.
Yes.
So L'Hopital's rule is phenomenal. The problem is once you introduce L'Hopital's rule, people want to use it on everything. You cannot use it unless you get the indeterminate form first. If it doesn't give you an indeterminate form, you have to do it the old-fashioned way. Boo.
Does it not work?
It doesn't work unless it's the indeterminate.
Yeah.
So me and this little Hopital dude are friends.
Yeah.
How much time did these people have on their hands to just think of these random?
You'd be sitting there like,
They didn't have TV or internet.
They're just sitting there thinking,
and they can't go over to their friend's house.
No, because they lived way too far away.
they're just sitting in the living room. Like,
Okay, so la, quit distracting me. Here
so
we go.
mathematicians didn't have friends.
So remember these 2 rules we had to memorize? Probably not, because you didn't memorize them.
No.
But I memorized them. I forgot them.
Okay, so we had these rules, and we went through like a reason why it worked, you know.
Yeah.
But when we tried to plug it in, it just didn't work out. So we memorized that the limit as x approaches 0 of sine x over x is 1.
Uh-huh.
And the limit as x approaches 0 of 1 minus cosine x over x is 0.
Yes.
But if we plug stuff in, we get the indeterminate form. And there was really no way to simplify that. Well, now, knowing that that gives me the indeterminate form, I can do L'Hopital's rule.
This could be like cosine of...
So what's the derivative of sine?
Cosine
Cosine.
over 1.
Cosine.
That's what I was doing. Oh, so it's just cosine.
So it's the cosine of 0, which, yeah, it's right here. It is 1.
So we got the same thing.
Yes.
But if we already knew it equals 1, then why did we do it?
Because if you remember...
Because we didn't know derivatives then. I couldn't show it to you because you'd have been like, what?
No, but we already knew it equaled 1.
Yes. Same thing with this rule. This one's supposed to equal 0. And if I plug in 0 right now, I get 0 over 0.
I don't know what is happening either.
No, my voice has been in and out for like a week.
This is cute.
So the derivative of negative cosine x. Derivative cosine of x is
Negative sign.
negative sign. So if you have a negative in front of it, it's positive sign over 1. And the sign of 0 is 0 because it's the y coordinate.
Oh, see, now you're making us on the next one.
Yeah, no one did know.
I'm good.
Who is blowing up my phone for why? It is 9:30 in the morning.
It's not me.
Like, literally stop.
Well, look.
It's probably the cheer group
Is
chat.
anybody important? You want me to answer it?
I don't know, but they just keep texting me. And I'm like,
What's the cheer group chat? That's my bet.
no, it's my council group chat. Go to school.
They all are in school.
They're all virtual.
Like, who are texting me? Go to school.
Okay, so I have to make sure that it's actually the indeterminate form before I can use L'Hopital's.
That's a lot of work.
That
I'm
is-
guessing if it's on the paper, it's going to be
0 on the bottom.
Yes. Pi over 2 minus pi over 2.
I think the top one's also 0 because I'm pretty sure that's the upper
Well, that's
one.
this one, yeah,
So it's 0.
which is 1, 0. And the x coordinate is 0, so yes.
Hold on.
I know my unit square.
The x coordinate's 1.
Yeah.
The
but-
y coordinate, I mean. Oh,
The x.
oh, I did it backwards.
Oh, so this one.
Sorry, I'm really bad.
I was like, the 1 is 1.
Yeah, the x coordinate is 0. I just wrote it down.
I was like,
I do that all the time.
great.
Thank you.
Perfect.
Sine x over.
So limit as x approaches pi over 2.
Oh, this isn't that hard.
No. Derivative of negative cosine,
Positive sine.
Sine.
positive sine of x.
Over
Derivative of x minus pi over 2,
1.
1. So it's a sine of pi over 2.
So it's
I know my unit square.
Square?
I know, I said square too, and then I think that made you say square.
Oh, okay. I thought you were. Okay, great.
So now I'm going to plug in 0.
0 times 7 is 0.
Wow.
And the sine of 0, I'm also guessing is 0. I'm probably wrong.
Yes, because we did that up here.
I don't know.
We did it right here. Sine of 0 is a 0.
0.
I was right.
Yes.
0 squared is still 0.
Yes.
And then the sine of 3 times 0 is 0.
Yes. Indeed.
I like the word 0.
Okay, so use L'Hopital.
7 minus cosine x over 2x plus. Did I get a little do-to-do thing?
No.
No, you have to chain them.
But that's gonna
Because
be
it's not sine times
So
3x.
then it's 3 cosine of x.
Yep.
But it's minus.
No.
Okay.
It'd be, okay, yeah.
Are we good? We'll lose anybody?
No.
Not yet.
Okay.
Okay.
So 7 minus cosine of 0
Over 2
over
times
0 plus
1.
3 cosine of 0.
So that's like 6 over
Yeah, cosine of 0 is how much?
1.
1.
And 3 times 1 is 3.
2. What?
Oh!
6 over 3. That's 2.
So it is 2,
Sorry.
yes. No, you're
She
fine.
said 2.
Yeah, I thought.
That's why I was like, what?
I wasn't looking up. I didn't see where you were.
No, that's fine. You're fine.
This one has to do.
No, it doesn't. Yes, it does. Just kidding.
If it gives me the tournament part.
That's right. You gotta check that out
Is-
first.
Okay, so it's
Top
going to be
tangent.
0 times 1. So
0 times anything is 0, right?
Yes. Especially times 1. Because anything times 1 is itself.
That is 0 over 0.
0 plus sine.
Alright. So it is in indeterminate form.
The derivative of so cosine x squared.
So you gotta do the product rule, right?
Cosine squared x.
I think, isn't there
Plus.
a derivative for cosine?
Negative sine x.
Why do you square it?
Because it's going to be,
You have to
it's
do
derivative of the first, so it's
I thought there's like some
x times the
cotangent.
second.
Oh,
No, you're thinking the opposite. If you have like when we do integrals, which your brain is primed for that, evidently. Try to catch up on your homework, y'all.
I know, we have like 8 more.
This kids are planning on doing